All right, the purpose of this video is to introduce you to the practical that you are going to be performing in our next lesson together. The aim of this investigation is to demonstrate that acids react with some metals to produce salt and hydrogen gas. The method is pretty straightforward. I'll begin by placing a piece of magnesium ribbon into a test tube. Now this bit needs to be done very quickly. Pour about 10 milliliters of acid on top of the metal and then very quickly cover the reaction with a second test tube held upside down over the first one. So you've got a right side up test tube that contains your magnesium and your metal. You've also got an upside down test tube held over top, directly over top of that reacting test tube. Try as best you can to make sure that there is no gap between the top of one test tube and the bottom of the other. When the reaction has finished, be careful to keep the test tube that is upside down in its position. So you want the upside down test tube to stay upside down. And while you're holding it, your lab partner will need to strike a match. As your lab partner approaches the test tube, the upside down test tube with the match, tilt the test tube toward the match just a little bit, maybe 10, 20 degrees at the most, and quickly light the lip of that test tube. If you've done all of this correctly, you have collected some hydrogen gas in the upside down test tube. And when you light the hydrogen gas with the burning match, it should cause a small explosion that will sound like a popping sound. You've probably heard it before. And then you can repeat the same experiment, but this time with zinc metal instead of magnesium. The magnesium will probably be totally consumed in the reaction, but the zinc metal, there'll probably be some left over. Your acid can be tipped down the sink, but we don't want the magnesium or the zinc metal pieces down the sink because they clog up the drains. So what you need to do is carefully pour off any leftover acid, but then dump the magnesium and the zinc metal into the bin. Okay, risk assessment. The most significant risk associated with this investigation is the fact that hydrochloric acid is corrosive. It can burn your eyes and irritate your skin. The eyes are especially vulnerable. Broken glassware can cause cuts. And in this particular prac, the surprise that you might experience when the hydrogen pops could be enough to cause you to suddenly drop the glassware and break it. So try not to do that. Hang on to your test tube. Wear your safety glasses at all times. That's the most important mitigation. Wear your safety glasses at all times and report any breakages of glassware to me immediately. Don't attempt to clean them up yourself. And that's really all there is to tomorrow's practical.